So our first premise, I know a couple of you, I can point you out, but I won't call you out, a couple serious quilters, okay? And to make a quilt, you need fabric. We have two constraints here. I'm going to have you start off by writing the constraints. The first constraint is that you're buying light and dark colors, and you need at least 9.5 yards of fabric. So when you buy fabric, it comes in yards, okay? You also have a budget constraint. You can't just spend all your money on quilts. You can only spend up to $110 on your fabric. You need to know that the light color costs a little less at $9 a yard, and the dark color is $13 a yard. I'm speculating that either the dark color is more desirable, so they jack the price up, or maybe the dye is more expensive. That's why it costs more. But either way, I need you to write down both constraints to get started here. All right, y'all, let's collect your constraints. Who's got the yardage constraint for me? Evan.
L plus D is bigger than or equal to 9.5.
So I'm going to do X plus Y just because I see it labeled on the graph, but you're good. I don't hate what you did there, okay? It needs to be greater than or equal to 9.5. That says I need at least 9.5 yards. And we actually see that on graph A. If we went all light fabric or all dark fabric, and the line is 9.5 yards, does 9.5 yards work?
Yeah.
Yes, and so does everything that's more than it. So that's why that is the graph for the first constraint. The second constraint, Evan.
9x plus 13y is less than or equal to 110.
Yeah, so that's our budget. The most we can spend is 110. There's if we bought only light-colored fabric. Here's where we bought only dark-colored fabric. And on the line is $110. But we can also spend anything less than that we would like, okay? So you got to make sure when we go to this next slide, you got those constraints down, okay? Because the next slide, I'm going to ask you some questions about these constraints. All right. So you already did number 1, and you already did number 3. So I want you to select all the pairs that satisfy the length constraint out of that list. So which one of those work for length? And then on number 4, I want you to select the pairs that work for the cost constraint. So jot those down. Which ones work for length? Which one works for cost? All right, let's take a look at 5.5. Does that make the length constraint 9.5?
Yes.
Yes. What about 2.5, 4.5?
No.
That's only 7 yards. 7.5, 3.5?
Yes.
That's 11. And then 12 and 10?
Yes.
Okay, all those work for length. Down here, let's see cost. 9 plus 13, is that less than or equal to 110?
Yes.
Okay. 4, 5.
Yes.
That's 36 plus 65.
Yes.
8, 3.
No.
72 and 39 does not work. 10 and 1.
No. Yes. No.
90 plus 13 is 103.
No. Yeah.
That does work. So, let's talk about 2, 2. Okay? Does it work for cost?
Yes.
Yeah, $18 plus $26 is $44, which is less than or equal to 110. Check, it works, right? Awesome, let's buy 2 and 2.
But it doesn't.
Oh, dang. That's only 4 yards?
Yeah.
And I need 9.5. So that only satisfies 1. So since we have 2 constraints, I need a point or points that satisfy both constraints, okay? So what I'm going to do to check your answers, actually, to make a point, is go back to the graphs. So who's got an ordered pair that would work? Finn?
12-0.
12-0, so let's check it out. Does it work for our length?
Yes.
And does it work for our cost?
Yes.
Okay, cool. Grant?
9-1.
Oops. So let's go to 9.1. Yeah, that works. It's just over yardage. Okay, and 9.1 totally is in the shaded part for the price. Olivia? 7.52. So 7.5 is right about here. 2's right on the line. That's right, that 9.5. Let's go over here. 7.5, 2. Yeah. Satisfied both. So what do you notice? All the answers that satisfy both, what are you noticing about the shaded regions of both?
They're both shaded.
It's in the part where the shaded regions overlap. So one great way to look at all those different answers, because how many answers theoretically are there? Infinite. So if I put this answer over here, okay, and it's a solid line because 9.5 works, and shade above,
It's that one little section.
do you see where they overlap? So the section where all of our answers are lying in that will satisfy both are right in there. So anything that's in that little region.
See that bottom line right there?
Yeah.
That's not real. It goes on for infinity because
This does
it only gets wider.
this does go on for infinity, however, in context, we can't get negative stuff. But the line itself that we use for a boundary, Owen, does go on. That's why context is really important. Okay?
Mr. Wright, there can be decimals.
Yeah, there can be decimals. What I'm saying is there's theoretical infinite answers in here. Now, what would happen is you could probably only get like point something of it. Like they're not going to go to 0.00006 yards or whatever.
Like they're not going to cut off.
So it's like a theoretical infinite, but all those answers that would work that you could get are going to be in that shaded region or on the line that outlines that shaded region. Okay? So that's kind of the new thing today. Now, just quick reference. We're going to skip this because we did it the other day, actually. So here's a system of inequalities. It's a lot like our system of linear equations. You may remember our linear equations crossed in no spots, all the spots, or one spot. Okay? These are going to cross in one region or sometimes maybe nowhere. Well, we're going to see some stuff today. So we'll see how these cross. But already we saw that they cross in like a region instead of just like a point. All right? And that's why we need the graph. We need to be able to draw it because we need to specify regions. And so here's what the solution looks like, kind of like we just saw. Where the two things overlap would be the solution. Because if you're going to satisfy all constraints, you have to satisfy the whole system. Both things in the system like we just saw with our quilting. So think of that next time you go to Joann's, okay? Or Michael's, whatever your place is, Bob. I don't know which one you prefer. So these are the ones. We're not going to look at these again. I'm just going to jog your memory. Do you guys remember the concert tickets where we made stuff and graphed stuff? Advertising packages.
I wasn't here.
Okay, but you should have watched the video notes and then notes. So, what we're going to do today is expand on that. So these high schoolers put together a scavenger hunt in a rectangle that's 50 by 20 meters. And if you want to find the step that's hidden, what they did is they made systems, and they're hidden in the area that satisfies the system. And in case you want to know, I've been looking for one of these for many years. The thing they hid in all these places, you know, just to help your imagination, it's I saw it at a gas station once. It's a little pig, and you can squeeze it, and poop kind of comes out and goes back in a little bit.
What?
Yeah. Some of them had snot, but one of them, you squeeze it, it's like a keychain. I've never seen one again. So I'm always on the lookout. I like to imagine that they're hidden in this part. That's what I'm imagining. So what you need to do is use the clues to find the areas that satisfy both constraints, both inequalities, and that's where that little poop pig is, all right? Let's find them. But let's get graphing these. Y is greater than 14. So that means that I have a horizontal line there. And a good way to know it's horizontal is I need a line that no matter where I'm at on the line, Y is 14 for my boundary. So it has to be horizontal, right? Everybody see that Y is 14 no matter where I'm at on that line?
Yep.
Okay? And then I'm going to do, this is called like a hatch mark method. I'm shading above because everything needs to be more than that. Does 14 work?
Yeah.
14 doesn't work. So for the next line, I need X to be less than 10. So I'm going to go to make the line where X is 10. Dash line. Okay? And less than that would be everything left. So I'm going to shade this way. And then you can see which region has both of them shaded.
Top left.
Yep, this top left region. So all that pig is going to be in that region. Can it be on a line? Cannot be on a line. Finn, let's look for the second one. The second one has X plus Y is 20. Standard form, I should be looking for intercepts. So here's my intercepts for the first one. Does the line work? No, it has to be less than. So dashed. Less than is the origin 0, 0. Does it work or no? Or yes? The origin does work. So we're going to shade below the origin. Below the line. So there's where this one works. And then x has to be less than 6. That means, does 6 work? 6 does not work, so I'm going to go to 6. Make my dash line. And less than that needs to work. So left of that. And then we should be able to find the region where those two things cross. And that is this region right here. Oh, I did that wrong. I did less. Why did I do less? Greater than. I shaded what I said. Now it's there. Okay. We got it. This one right here. All right. Third one. These lines are parallel. They have the same slope. Let's see what happens. I have a y-intercept of 20. A slope of -2. Dash line. All right. Let's test the origin. Is 0 less than 20? Yes, so everything underneath works. All right, let's get our other line. Y-intercept of 10. Slope of -2. Down 2, right 1. Oh, my thing's not happy unless I... Okay. Goes through there. And it has to be less than that. Which is down there. Look where they cross. In this little teeny section right here.
Well, it's technically speaking.
Okay. Last one. So it says there is one with no answer. So hopefully this last one has no answer because we've gotten answers every time. Even the time I screwed up, we got an answer. So slope-intercept form, we should use the y-intercept and slope. I have a y-intercept of 10. A slope of 1. Guess what, guys? Solid line, baby. Because the line works. I'm going to test the origin. Is 0 greater than 10? Nope, so the origin should not be shaded, so I'm going to shade above. Okay, next one, I like to rewrite this as y is less than x. It's the same inequality, but this just helps me find the y-intercept and slope because it's like in y equals mx plus b form. So the y-intercept is 0. The slope is 1. If it's less than, does the line work? No. Nope, the line does not work. So here is my line. And it's less than that, so I'm going to shade under that. And if I shade under that, see where they cross?
No, I don't.
Yeah, because they... Ooh, that's like watermelon. But they do not cross. So guess what?
No solution.
No solution.
Rewrite the inequality.
No, nothing's hidden there, maybe. Yeah. Maybe that's what happened. Okay, so let's talk real quick. Let's talk real quick. What's the difference between a system of lines and a system of inequalities? What's the difference?
A system of
What-
inequalities.
Ellie.
You can find like what points work for a system of inequalities.
Yeah, so there's like a bunch of points that are in a region, right? All these. And if you had the system, which one does it work in? Which constraint? Both constraints. Same as the linear inequality, but the linear equality, or the system of equations, in this case, how many points satisfy this? 1 point right there. Okay? That's the difference. That's why we need a region. Because there's a bunch of points that work to satisfy two constraints sometimes. So we graph it, and we see where it's extra shady, right? Awesome. So let's make sure we can do these things. Can we write a system? Yes. Do we know what it means by solution to the system?
Yes.
Yes, it satisfies both. And when we're given the descriptions and graph, what does it look like at the solution?
It's shaded.
Double extra shady. Okay? All right. Back to your science, please.